Okay, the last topic in this section is solving quadratic trig equations. And we're going to split this over two videos. The main idea here is if you're given an equation like this where you've got sine squared and then sine, what you can do is you can treat that sine like it's one big variable. So if you wanted to, you could come down here and rewrite it. Like you could say let x or not x. We need a different variable. You could say like let u equal sine x. And so u squared is sine squared x. That will let you rewrite this as 2u squared plus u minus 1 equals 0. And then you can solve that like it's a plain old quadratic equation. Let's see, how can we factor this thing? Looks like we could factor it into 2u and u. Put some 1's there. And we want to make that u in the middle positive, so I'll make this plus and this minus. And that way we'll get 2u minus u gives you u. All right. So this gives us, from this side, we get 2u minus 1 equals 0. I'm going to go ahead and move that over. 2u is equal to 1. So u is a half. And this gives me u equals negative 1. But remember, u is sine x. So this becomes the equation sine x equals 1/2. This becomes the equation sine x equals negative 1. So let's see, this right here, my reference angle, is what has a sine of a half? Pi over 6. And we're going to put that into quadrants 1 and 2. So that's going to give me pi over 6. Over here, this is going to give me 5 pi over 6. So that's two solutions. I'm going to move this over here. So sine x equals negative 1. Remember, sine is the y-coordinate here. So y is negative 1 down here, and that's at 3 pi over 2. So we get three solutions to this thing. We get 5 pi over 6, 3 pi over 2, and pi over 6. Written there in no particular order. So three solutions. Let's check it. You know, why am I so obsessed with checking? I like to check all my problems. Well, you know, I guess it's because if I were taking this class, I would want to check all of my answers before I, turn something in. So let's look at how to check this. Probably what I would do would just be put in y equals 2 sine squared x plus sine x minus 1. And let's see, it doesn't like that because it left the x up there. All right, so we get this. And if we're looking between 0 and 2 pi, so if we do that, we've got, we're looking for the places where this equation is equal to 0. And it happens right here at pi over 6. Again here at 5 pi over 6. And again over here at 3 pi over 2. So it checks out. We're good. All right, let's do one more example in this video. Solve cosine squared x equals, or minus 1 equals 0 on 0 to 2 pi. Now there are two ways you could do this. You could take this and say, oh, well, cosine squared x then is 1. And take the square root of both sides and get cosine x is plus or minus 1. And there's nothing wrong with doing that. This would split into cosine x is 1 and cosine x is negative 1. Remember, cosine is the x-coordinate, so that could be here or here. So that gets me two solutions x equals 0, x equals pi. And it's perfectly fine to do that. And for whatever reason, when I was a student, that seemed like the most logical way to do it. The only thing is, if you do that, make sure you don't forget that plus or minus, because if you leave the minus off, you lose the solution. To me as a student, for some reason, that seemed to be the logical way to do this. For me as a teacher, for some reason, it seems more logical to factor this into cosine x. Well, to notice that this is a difference of two squares. So you can write it as cosine x minus 1 times cosine x plus 1 equals 0. And then this will give you cosine x equals 1, and the other one will give you cosine x equals negative 1. And of course, from there, you're right back where you started. For some reason, that seems more logical to me now. But they both work. Also, this is one way to come up with the solutions, is by drawing it on here. The other thing you could do is you could draw out the cosine graph between 0 and 2 pi and just look and see, when is this thing equal to 1 or negative 1? Well, it happens here and here for 1 and negative 1, and that's at 0 and pi. You might say it happens over here too. That's true, but notice when it says to solve it on this interval, notice the 2 pi is not included, so you don't want to include that. All right, so that's two examples, and we've got two more, but I'll put those in the next